The first question is, if a to the power x equals to m, a to the power y equals to n, and a square equals to m to the power y into n to the power x to the power of z, then prove that x, y, z equals to 1. To start this problem, we have to start with the given conditions. What are the given condition? The given condition are a to the power x equals to m, a to the power y equals to n, and a square equals to m to the power y into n to the power x to the power of z. We are seeing that m has a power y and n has a power x. To get that thing, so we have to do this thing: a to the power x to the power of y, m to the power of y. Now a to the power y to the power of x, n to the power of x. Now a to the power of xy equals to m to the power y, and a to the power of xy equals to n to the power of x. Now this is number 1 and this is number 2. Now we will going to put this value, number 1 and the number 2, value of the number 1 and the number 2 over here. The third condition. What is the third condition? Third condition is a square equals to m to the power y into n to the power x to the power of z. Now a square equals to, we can write m to the power y as a to the power xy, we can write n to the power x as a to the power xy to the power of z. Now a square equals to a to the power 2xy whole to the power of z. Now a square equals to a to the power 2xyz equals to, if the base is equal, then base will be cancelled out, then 2 equals to 2xyz. Now xyz equals to 1, proven. So this is how we will going to prove this kind of problems. Now the second problem. The second problem is, if a to the power x equals to b to the power y equals to c to the power z, and b square equals to ac, then prove that 1 by x plus 1 by z equals to 2 by y. Now a to the power x equals to b to the power y, c to the power z. Now k not equals to 0. Now we can write it: a equals to k to the power 1 by x, b equals to k to the power 1 by y, and c equals to k to the power 1 by z. And we have to put all these conditions in third condition. Third condition is b square equals to ac. So in place of b, we can put k to the power 1 by y whole square into k to the power 1 by x into k to the power 1 by z. Now k to the power 2 by y equals to k to the power 1 by x plus 1 by z. Why? Because a to the power m into a to the power n equals to a to the power m plus n. Now if the base is equal, then base will be cancelled out, then 2 by y equals to 1 by x plus 1 by z. Proven. You can see that this is proven. Now the next question is, show that x cube minus 6x square plus 6x minus 2 equals to 0 when the condition is x equals to 2 plus 2 to the power 2 third plus 2 to the power 1 third. This is the question which was asked in 1974 West Bengal Higher Secondary examination. Now we will going to use the given condition. The given condition is x equal to 2 plus 2 third, 2 to the power 2 third plus 2 to the power 1 third. Now x minus 2 equals to 2 to the power 2 third plus 2 to the power 1 third. Here we can see we have to prove x cube minus 6x square. How we will going to get x cube and x square? To get that, we have to cube both side. So we have to cube both side. So now x minus 2 whole cube equals to 2 to the power 2 third plus 2 to the power 1 third whole cube. So what is the algebraic formula of a plus b whole cube? The algebraic formula is a cube plus b cube plus 3ab into a plus b. Now x cube minus 3 into x square into 2 plus 3 into x into 2 square minus 2 cube equals to 2 2/3 whole cube plus 2 to the power 1/3 whole cube plus 3 into 2 to the power 2/3 into 2 to the power 1/3 into 2 to the power 2/3 plus 2 to the power 1/3. Now x cube minus 6x square plus 12x minus 8 equals to 2 square plus 2 plus 3 into 2 to the power 2/3 plus 1/3 into 2 to the power 2/3 plus 2 to the power 1/3. Now x cube minus 6x square plus 12x minus 8 equals to 4 plus 2 plus 3 into 2 into x minus 2. Why I am putting x minus 2? Because the given condition I made x minus 2 equals to 2 to the power 2/3 plus 2 to the power 1/3. That is why in place of 2 to the power 2/3 plus 2 to the power 1/3 I am putting x minus 2. Now x cube minus 6x square plus 12x minus 8 plus 6 plus 6x minus 12. Now we will going to shift all the right hand side onto the left hand side. Minus 6 plus 12 minus 6x equals to 0. Now x cube minus 6x square plus 6x minus 2 equals to 0. Proven. I hope you understand. Now the next problem. The next problem is if x to the power 1 by a equals to y to the power 1 by b equals to z to the power 1 by c and xyz equals to 1, then prove that a plus b plus c equals to 0. This is quite an easy one. This is one of the easiest mathematics I will going to show you. X to the power 1 by a, y to the power 1 by b equals to z to the power 1 by c equals to k, and k not equals to 0. So x to the power 1 by a equals to k, y to the power 1 by b equals to k, and z to the power 1 by c equals to k. We can write it as x equals to k to the power a, y equals to k to the power b, and z equals to k to the power c. Now we will going to put x, y, z in the third condition. The second condition is x, y, z equals to 1. That means in place of x we will going to put k to the power a, k to the power b in place of y, and k to the power c in place of z equals to 1. So k to the power a plus b plus c, because base is equal, that is why we will going to add all the indexes. Now what is 1 equals to? The 1 equals to k to the power 0, because any to the power 0 equals to 1. Now if the base is equal, then base will be removed. Now a plus b plus c equals to 0. So this is proven. So this is quite an easy one. The next one is also easy, but I will going to prove it in front of you. Now the next one is if p to the power a equals to q to the power b equals to r to the power c and p q r equals to 1, then show that AB plus BC plus CA equals to 0. This was the question was asked in 1998 Higher Secondary Examination of West Bengal. Now the proof is again the same way we will going to prove it. P to the power A, Q to the power B equals to R to the power C equals to K, and K not equals to 0. The same way in the previous problem we took x to the power 1 by a equals to y to the power 1 by b equals to z to the power 1 by c equals to k. In this problem the p to the power a equals to q to the power b equals to r to the power c equals to k. Now we can write p equals to k to the power 1 by a, now q equals to k to the power 1 by b, and r equals to k to the power 1 by c. Now let's put all this thing in the second condition. Second condition is PQR equals to 1. So in place of P we can write k to the power 1 by A into, in place of Q we can put k to the power 1 by B. Now in place of R we can put k to the power 1 by C, that is equals to 1. Now k to the power 1 by A plus 1 by B plus 1 by C. In place of 1 we can write k to the power 0, as if the base is equal, so that is why the index will be equal. Index, right hand side index and the left hand side index will be equal. Now we will going to sum it. ABC equals to BC plus AC plus AB equals to 0. So right hand side and left hand side multiplication, ABC will multiply it with 0, then it will be 0. Now we can write it AB plus BC plus CA equals to 0. Proven. Now the next problem. The next problem is quite similar to this one. The similar in the sense is that the way we solved the previous two problems, these problems we are going to solve by using that method. So the next problem is, what is the next problem? Next problem is, if 2 to the power x equals to 3 to the power y equals to 12 to the power z, then prove that. Sometimes they will going to ask prove that, or sometimes they will going to ask show that. Meaning is same. They prove that xy equals to z into x plus 2y. So let's take again 2 to the power x equals to 3 to the power y equals to 12 to the power z equals to k, and k not equals to 0. K should not be 0. Now 2 to the power x equals to k, 3 to the power y equals to k, and 12 to the power z equals to k. So now 2 equals to k to the power 1 by x, 3 equals to k to the power 1 by y, and 12 equals to k to the power 1 by z. So after factorization of the 12, what we will going to get? We will going to get 2 of 6, 3. That means 2 square into 3. We can write 12 as 2 square into 3. Now we will going to put value of 2 over here in the third conditions. That means k to the power 2 by x into k to the power 1 by y equals to k to the power 1 by z. Now we will going to apply the same formula. A to the power m into a to the power n equals to a to the power m plus n. Now 2 to the power x plus 1 by y equals to k to the power 1 by z. Now as the base is equal, that is why the indexes, whatever the index we have, the index will be equal, left hand side index will be equal to the right hand side index. So 1 by z. Now this is, now we will going to sum of this function. Now we will going to get 2y plus x equals to 1 by z. That means xy equals to z into 2y plus x. This is the proof. So this is the quite easy one. Now the next one is, if 64 to the power x equal to 48 to the power y equals to 36 to the power z, then prove that 1 by x plus 1 by z equals to 2 by y. So now 64 to the power x equals to 48 to the power y equals to 36 to the power z equals to k, the same way, and k not equals to 0. Now 64 equals to k to the power 1 by x, 48 equals to k to the power 1 by y, and 36 equals to k to the power 1 by z. We can write 64 as h square equals to k to the power 1 by x, and 48 as 6 into 8 to the power k to the power 1 by y, and we can write 36 as 6 square equals to 1 by z. Now we can write 8 as 1 by 2x equal to 6 into 8 equals to k to the power 1 by y, and 6 equals to k to the power 1 by 2z. Now we will going to put value of 8 over here and value of 6 over here. Now 6 equals to k to the power 1 by 2z into 8 equals to k to the power 1 by 2x equals to k to the power 1 by y. Again, as the base is equal, then we will going to sum the indexes. 1 by 2x equals to k to the power 1 by y. So 1 by 2z plus 1 by 2x equal to 1 by y. We can take half common from this function. Now 1 by x plus 1 by z equals to 1 by y. Now multiply 1 by x plus 1 by z equals to 2 by y. Cross multiplication proven. So this is the proof. A to the power x equals to b to the power y equals to c to the power z equals to d to the power w, and another condition is ab equals to cd. Then prove that xy equal into z plus w equals to zw into x plus y. Same way we will going to take a to the power x equals to b to the power y equals to c to the power z equals to d to the power w as k, and again k not equals to 0. Now a equals to k to the power 1 by x, b equals to k to the power 1 by y, c equals to k to the power 1 by z, and d equals to k to the power 1 by w. Now we will going to put all the values in second condition. What is the second condition? Second condition is ab equals to cd. What is the value of a? A is, in the place of a we will going to put k into 1 by x. In the place of b we will going to put, in the value of a we put k to the power 1 by x, and in place of b we put k to the power 1 by y. Now equals to c equals to k to the power 1 by z, and d equals to k to the power 1 by w. Now k to the power 1 by x plus 1 by y equals to k to the power 1 by z plus 1 by w. Now index will be equal to each other. Now we will going to do the sum. Now we will going to do the cross multiplication. Now zw equals zw into x plus y equals to xy into z plus w. You can see this is the proof they asked for. Now this is proven. Now the next problem. Next problem is quite different from the previous ones. The problem is x equals to root over 5 minus 2 to the power 1/3, then show that is quite similar to the proven that. So x minus x to the power minus 1 whole cube plus 3 into x minus x to the power minus 1 plus 4 equals to 0. Now what is given? The given thing is x equals to root over 5 minus 2 1/3. Now what is the value of 1 by x, which is also equals to x to the power minus 1? That is 1 by root over 5 minus 2 to the power of 1/3. Now after reduction, after using the formula of surge, we will going to get root over 5 plus 2 to the power of 1/3. Now 1 minus 2, what we will going to get? 1 minus 1 by x equals to root over 5 minus 2 1/3 minus root over 5 plus 2 1/3. Now we will going to cube both side. Cube both side. Now x minus 1 by x whole cube equals to root over 5 minus 2 1/3 minus root over 5 plus 2 1/3, now whole cube. What is the formula? The algebraic formula we will going to use, that is 1 minus b whole cube equals to a cube minus b cube minus 3ab into a minus b. Now root over 5 minus 2 1/3 whole cube minus root over 5 plus 2 to the power 1/3 whole cube minus 3 into root over 5 minus 2 into root over 5 plus 2 1/3 power. Now root over 5 minus 2 to the power 1/3 minus root over 5 plus 2 to the power 1/3. Now we can write it as root over 5 minus 2, because 3 and the 3 will cancel out each other, because when we will going to use the formula of a to the power m whole to the power n, then we will going to multiply the powers. This is the way we will going to cancel out the powers. Now root over 5 plus 2 and 3 into root over 5 square minus 2 square whole to the power 1 cube. Now in the place of root over 5 minus 2 1/3 and minus of root over 5 plus 2 1/3, we can put which is x minus 1 by x, because this is similar to the x minus 1 by x. Now root over 5 minus 2 minus of root over 5 minus 2 minus of 1 into x minus 1 by x. So plus root over 5 minus root over 5 plus minus will be 0. Now minus 4 minus 3 into x minus 1 by x equals to x minus 1 by x whole cube. Now 1 by x, we can write 1 by x as x to the power minus 1. So x minus x to the power minus 1 whole cube plus 3 into x minus x to the power minus 1 plus 4 equals to 0. Proven. So this is a quite easy one, but not similar to the previous ones. Now the next problem. The next problem is, if x to the power n cube 2 to the power of n equals to x to the power 3 to the power n power of cube, then show that n plus 1 root of n to the power 4 equals to 3. So how we will going to prove it? Let's write what is given. We will going to use the formula a to the power m whole to the power n. Now we will going to multiply the power a to the power mn. In this case we will going to do the same. N cube into n equals to 3 to the power n into 3. Now x to the power n 3 plus 1 equals to x to the power 3 to the power n plus 1. Now x to the power n to the power 4 equals to x to the power 3 to the power n plus 1. Now base will cancel out each other. Now power, left hand side power and right hand side power is equals to, now multiply both side with 1 by n plus 1 power. So 3 to the power n plus 1 whole to the power 1 by n plus 1. Now we can write it as n plus 1 root of n to the power 4. Now 3. Answer. Not answer, it's proven.